Hello, it's Andrew Glaser from the Glaser Tutoring Company, where you can learn from the best. Today I would like to teach you how to use the Rational Zero Theorem in order to find the real zeros of this polynomial function of 2x cubed minus 3x squared plus 4x plus 3. Now, first of all, what in the world is the Rational Zero Theorem? Well, it basically says that if you take the factors of your constant term in the polynomial, call them p, and you take the factors of your leading coefficient, which is the coefficient of the highest power of x, call them q, and you then divide those two values one by the other, you get a list. If I could only write q, that'd be great. You would get now a list of possible rational, which means that they're real, zeros. Okay? Now, what are the factors of 3? Well, remember, factors are whole numbers that multiply to that value. So all I can think of is 2, meaning a 1, and a 3. Now just simply put a positive and negative next to each one of them, because technically, right, to get positive 3, you either take positive 1 multiplied by positive 3, or you take negative 1 multiplied by negative 3. So as you can see, there's really, technically, I guess, 4 values there. And then what are the factors of 2? That's easy. It's a 1 and a 2. And again, positive, negative. Now, what you would do is now you would try to identify all the possible combinations between a single numerator value and a single denominator value. All right, so you take positive 1 divided by technically, yes, positive 1 divided by positive 1 will give you positive 1, right? Negative 1 divided by negative 1, blah, blah, blah. But it's just easier to do it this way. Take the positive negative 1, divide it then by the positive negative 1, and what results is just do the division there between the 1, so that's a 1, and then all you got to do is do a plus and minus, right? So you're really going to have two values, positive and negative 1. Then you're going to do the positive negative 3 divided by the positive negative 1. So obviously that's going to give you the same thing in terms of positive and negative 3. Then you're going to do the same thing now, but you're going to work with the other denominators. So you're going to do plus minus 1 divided by plus minus 2. So that'll give you plus minus 1/2. And then you're going to do the last, right, 3 over 2 plus minus 3 over 2. So you really have 4 types of values, but in total you technically have 8, because each one of them is a plus minus. So now, what we can do here to kind of, so this is the list. I'm not saying they're all right. Maybe one of them is good. Maybe 2 of them, who knows? But the idea now, or the theory, is that we can use this idea of like the remainder theorem, where we can take one of these 8 values, plug it in for x, and if they work and they give a resulting value of 0 to this function, then that value that you plugged in for x is a real 0. Okay? That's what it means to be a real 0. A 0 is a value of x that gives an overall value of 0 for the function. So watch, I'm going to do one of the, I got a 1 in 8 shot, right? 1 out of 8 chance. So let's just choose positive 1. Now this is very inefficient. I'm going to show you a better way to do it in a second. But if you didn't have a calculator, I mean, this is what you're looking to do now. You're going to plug in 1, positive 1, everywhere you have x, and then you're going to hope that this works out to be 0. So 2 minus 3 plus 4, this isn't looking too good, plus 3 is equal to 0, huh? No, it's not. What that means is that the number you plugged in here, 1, is not a 0. That's great. Now you got 7 more to go, right? I mean, this is kind of a little bit ridiculous and very inefficient. So what I would look to do here is let's just gain a little bit of an insight by graphing the thing, all right? So let's just plug it into y equals, so 2x cubed, all right? 2x cubed minus 3x squared, great, plus 4x plus 3, and then hit graph. Now, as you can see, it's a cubic, right? So it kind of comes up here, and it's going to just trail on up and up forever. All right, it's going to come on down and down and down and forever as well. So what I realize here is that there's only going to be now, there's a maximum of 3 zeros for the function because it's a cubic. Now the real zeros will be the values that intersect the x-axis. So the thing is, though, that there's only one value here of x that intersects the x-axis. Only one. Now each one of these tick marks represents a unit of 1, and therefore when you move to the left it's negative, but you didn't go a full box. It looks like you went maybe a half of a box. So the value here, the x value, is going to be negative 1/2. Now, what's interesting is that now it's estimated to be, right? I'm going to prove it to you by plugging in the value, but it appears to me visually, upon visual inspection, that this is about negative 1/2. And if you notice, what's interesting is that, oh, that was one of the possibilities, negative 1/2, right? 1 out of the 8. Great. So what should happen now, since I have this little bit of an insight, all right, since now I don't have to test 8 values, I'm going to plug in then the negative 1/2 for every x. And what should happen now, if this is going to work properly, and if my assumption that that value was negative 1/2, that it wasn't a little, off, is going to be, the result in here is going to be 0. All right. So let's see what happens. So let's go to the calculator. I don't want to think. So just put the parentheses, take negative 1 divided by 2, and then cube it. All right, whenever you plug in values, please use parentheses. And that's minus 3, open parentheses, then negative 1/2. Close those parentheses, square that. Then go plus 4, open parentheses, negative 1/2. Great, and then plus 3. And then hit enter. Oh my goodness, look, it equals 0. So I was right? I mean, it is a negative 1. It looked like a negative 1/2. So this is a real 0. Okay, not only is it real, but it's also rational. All right. Now, you can also, by the way, go back to your graph and you can, let me zoom in a little bit. Let me go zoom in. So you can also find the 0 here, or the value of x squared across the x-axis by using this calc function, by the way. Go to second trace, so you're under calculate, calc, and then go down to find the 0 value. Hit enter. Now what you're going to do is you're going to move your cursor, all right, so that you're to the left of this intersection point. So you're going to move the cursor and, somewhere to the left. Okay, great, that's to the left. Hit enter. Then you got to move to the right. Just go to the right somewhere. Okay, good, hit enter. And now estimate, roughly. You don't have to be right on the mark. If you're over here, it's still going to calculate it. If you're over here, you're still going to calculate it. But try to get to the as close as possible. Hit enter, and look, negative 0.5. The calculator calculated it for you in that way. All right? Now, since I know that this graph only intersects the x-axis at one point, I know the remaining zeros are going to be imaginary. They're going to be imaginary. Okay? And that's going to be the only real 0 of the function now. And that's it. All right? You can find the imaginary values if you like. What you would do is you would do a division. Okay? You would have to then take the factor of this 0. So in other words, you would divide this function by x plus 1/2. You would do your division here. You would get a resulting quadratic equation. Your quadratic equation will be some a value squared plus some b value times x plus some c value. And then what you would do is you would find the roots or the zeros of this. You would use your a, your b, and your c value. You can then plug that into the quadratic equation, right? Negative b plus or minus the square root of b squared minus 4ac, all over then 2a. And you would find then that under the radical, you'll have a negative value. All right, so actually you don't really need to do all this stuff. You can just evaluate the discriminant. And you find your b value, plug it in and square it. Take your a value, plug it in there, take your c value, plug it in there, and you'll notice that this thing under the radical works out to be a negative number, which means that all the resulting values are going to be imaginary. All right? So hopefully that helps. If you want to see that done, I don't even know. Check out the playlist where this is, because I think I did that in almost every other problem. So, yeah, I'm just a little tired of it right now. Don't mind me. That's what happens when you do 15 of the same problems. Anyway, thanks for tuning in. Check out our channel because we have thousands of videos out there, not only in math, but physics, chemistry as well. We have a lot of stuff coming as well. We want to help you through your class, and we solve specific problems. It's the best way to do well. Take care.